Hello, and welcome to this video on gravitational potential energy example calculations for GCSE Physics and Combined Physics. And don't forget to like and subscribe. As we have seen, gravitational potential energy of an object depends on its height and its mass and the gravitational field strength. The higher the object, the greater the gravitational potential energy, and the larger the mass, the greater the gravitational potential energy. And the larger the gravitational field strength, the larger the gravitational potential energy. The relationship between these variables is as follows. Gravitational potential energy equals the mass times the gravitational field strength times the height. Or in symbols, this is EP equals mgh. The units for gravitational potential energy, EP, are joules. Mass, m, is in kilograms. Gravitational field strength, g, is in newtons per kilogram. And height, h, is in meters. A drone of mass 1.3 kilograms loses power and falls a distance of 20 meters. Calculate the energy lost from the gravitational potential store and give the answer to two significant figures. First, we need our equation, which is gravitational potential energy equals the mass times the gravitational field strength times the height, or EP equals mgh. And once we have our equation, the next thing to do is substitute the numbers from the question into the equation. So we have our mass, which is 1.3. Our gravitational field strength on Earth is 9.8 newtons per kilogram, and our loss in height is 20 meters. So as you can see, we've substituted those into the equation. Once we have that, we've got our instruction for working out our answer, and our answer is 254.8 joules, or to two significant figures, that's 250 joules. A toy plane is raised by a height of 0.8 metres and its gravitational potential store gains 1.2 joules. Calculate the mass of the toy plane. First, we start with our equation, which is gravitational potential energy equals the mass times the gravitational field strength times the height. And once we have our equation, the next thing to do is substitute the numbers from the question into the equation. So we get 1.2 equals the mass, our unknown, times by 9.8, our gravitational field strength, times by 0.8, which is the height that the toy plane has been raised by. Our masses are unknown, so we need to rearrange the equation to make m the subject. And to do this, we divide both sides of the equation by 9.8 and by 0.8. And that gives us our expression here. Now what we can do is we can cancel, and then we have an expression for calculating the mass. So 9.8 divided by 9.8 cancels, and 0.8 divided by 0.8 also cancels. And that gives us 1.2 divided by the multiplication of 9.8 and 0.8, and that gives us our mass and our final answer of 0.15 kilograms. A rover on Mars with a chemical store of 7,200,000 joules per Mars day is attempting to climb the highest mountain on Mars, a height of 21.9 kilometres. Does the rover have enough energy to make the climb in one day? The gravitational field strength on Mars is 3.7 newtons per kilogram, and the mass of the rover is 1,025 kilograms. Our equation is gravitational potential energy equals the mass times the gravitational field strength times the height. And once we have the equation, the next thing to do is substitute the numbers from the question into the equation. This gives us gravitational potential energy equals our mass, 1,025, multiplied by our gravitational field strength on Mars, which is 3.7, multiplied by our height, which we have converted into meters from kilometers, which gives us a value of 219,000 meters. Multiply these together and that gives us our answer of 83,055,750 joules. So our rover would not be able to make this climb in one day. To find the number of days it would take, we divide our gravitational potential energy answer by the chemical store value for each day which the rover has, and we end up with a final answer of 11.5 days. And that's all for this video. Thank you so much for listening.